Great, so we can start our session. So I want to know if you managed to do some research on the topic of bounded generics and wildcards and what you managed to understand by that topic. Yeah, so anyone with an idea of what bounded types are or what that even means? Anyone have an idea? What about if we do a quiz on bounded generics and wildcards? Right? So we are supposed to have read at least something about it before we come to class. Isn't it how it should be? Yes.
Certain types are looking at things.
Yeah, that's true. Anyone else? Yes.
I think the level is how you think the that kind of has to accept only such items that are arrayed. For example, you can just declare a generic saying it's a having T type, but that type must accept only numbers or strings. We're using extend keyword from there.
Yeah, that's true. Anyone else? Okay. So yeah, let's go. So bounded types in generics are most of the times used when you want to put some restrictions on generics, right? And as we have been saying it the last time, generics can be used to generalize, to create a general structure to use. Maybe let's say you have a class, or you want that class to be used to do different things, right? And we saw an example of a box class where you can have a box of integers, a box of numbers, a box of strings. And at that time, it was fine, right? I think let me get the file we used last time. Yeah, this one. Here we had box class, and it had the T was representing any type you wanted to use, right? And we were just calling it in the main class. What did we call box? Can find it here. But you remember how we were using the box class the last time, right? So now the question can be, even though we are using the box class to specify like to create a class that can be reused, sometimes you may want to restrict how the type of data types you want to get, right? So this is where the concept of bounded types in generics comes in, right? As you can understand, the word bounded is kind of similar to the word boundary, right? So now you're setting a boundary on what your class is allowed to accept as types, right? So now let's start by recreating the other box class we had the last time, and then add now extra features to it. So let's start with a box class. So our box class here, what we had the last time was something that looked like this, right? This is what we had the last time. And in this scenario, we would come here and call this. And for example, create a box of integers. And let me add just a value 2. So this box is receiving a value like integers only. And you could also come here and create a box of strings. And at this time, from what we had seen last time, this was fine. Let me say, right? But now we might say, okay, this box is fine. We can use it to just create classes or object with any kind of data type. But no, I want to only accept numbers, right? In the box. So anything that is a number, that's fine. For example, integers, doubles, floats, that's fine. But except for strings. In this scenario, this is where you are going to come here and add extends number, right? In this scenario, if you say extends number, it means that the type you have here needs to be a child class of number. So number, we are going to be treating it as the superclass or the parent class, right? And then the only types that we are allowed to provide here are the types that are subclasses or children of the number class. So in numbers, we have integers, we have doubles, we have floats, right? So those are the only ones that I'm going to be allowed to use if I'm calling this box class. So automatically, I guess you can see that the strings here are not allowed, right? So this is what we call, how do we call this? Upper or lower bounded? Upper, right? So why upper? Sometimes it can be confusing when you're going to be something called lower bounded, upper bounded. Why do we call it upper? Let me go back to
Subclasses of numbers.
Mhm.
The number is the one to the highest or to the highest point. So the subclasses of numbers will accept it.
Yeah, that's true. The upper, we are talking about this one. So we are going to use the subclasses that are inside the number class, right? So this is upper bounded, right? So in this scenario, instead of string, then we would use, for example, double would still be fine. And may add maybe 2 and 4. So this is allowed, right? So as you understand, remember, the reason why we are dealing with bounded, the reason why we're dealing with bounded types is to put some restrictions on our generics, right? Even though generics are good, we can create a class that can be reused, but at sometimes you need to set some limits, right? So this is the first example. Now let's look at another different example where we are going to use lower bounded generics. Now here in the box, so now let me create here in the main class a function and call it add number, public static add numbers. So this function, I'm going to be giving it a list of maybe some numbers, right? And then it's going to be adding them. So normally I would define it like this without having any kind of generics. Let me call it list. And then if I wanted to add these numbers, I would call list and then add add numbers. Let me see. Okay, let's say, for example, we have a list already here, and we want to add these numbers to this list. Trying to find a way to define this. Okay, yeah. So we are going to be adding a number here. Let me just provide the input for that number. So I'm going to provide, let me say, an integer. And here we are having a here. So here, if you wanted, for example, if a function or a method where you're going to be providing a list and then a number to add to that list, then let's say this is the simplest way you could do it, right? But at times you might say, I want to also be a little bit strict here, right? I just want to only accept integers and other things above integers, right? Because you see here, we're just receiving everything that is under the number subclass, right? Under the number subclass, the subclass is it includes integers, doubles, and any other thing, right? But here, we're going to define a function that's going to only receive integers and superclasses, right? So if I say integers and superclasses, I'm talking about directly number class, right? And then object class, right? But not double, floats, and other things, right? So the way we would do it here, we would put some parameters here, and then we put a question mark, then super, and define integer. And that's to pay attention to the difference we have here, right? And let me even confirm if, yeah. Okay, so now look at what you have here. Here you have super, right? Integer, and here we have extends number, right? So pay attention to these differences. So what this means is the only thing I'm allowed to provide here as the input is an array, is a list of integers or or values that are of number class or values that are of object class. So for example, let's see how it would look like if I would call it in the main class. Let me, for example, start with a list of integers. Integer list, new integer or new array list, sorry. And then I close. Let me also create other lists here. I'm going to use a list of number and a list of object. Okay, so now let me call the add number function. If I add the integer list and provide 3 as the number I want to add, this is fine, right? If I call add number and call the number list and provide 3, this is fine, right? Because 3 is still a number, right? If I call add number and provide object list and provide 3, it will still be fine, right? But if, for example, I was to provide a double, this would not work, right? Simply because in our boundaries, we've specified that we are only allowed to use any. This is what these question marks mean. Use any other types that are either integer or above integer or superclasses of integer, right? But as you know, a double is not a superclass of an integer, right? But yet here, what you're saying is We want every type which is a subclass of number. And as subclasses of numbers, we have integers, doubles, floats, maybe long, big, int, and so on, right? I feel like the difference between the two here is clear, right? Is it clear? Is it clear? Okay. So now let's look at one thing that we've been saying, wildcards, right? So anyone with an idea of what wildcards mean? Yeah, we applied the wildcard, but yeah, okay, yeah, okay, this one was a wildcard, yeah, but now generally, when do we use wildcards? They don't understand, they don't hear you. Mili, did you hear what she said? It says you use wildcards when you don't want to specify the data type. Okay, when you don't want to specify the data type you will use, right? So in general, wildcards, they simply give you flexibility, right? When the exact data type is not yet known, right? So you can, it's more of the concept you're talking about the way generics can help you to be flexible, and this is mainly wildcards do it better, right? And we are going to see two different types of wildcards, just as we were saying on bounded generics, upper bounded and lower bounded. They're going to be a little bit similar. And we have three types of wildcards. The first one is just the first one is almost like a common generic. So let me just show you how it looks like. Public static void, maybe let me call this print list. And this one is going to be receiving a list of items we have, and it prints that list, right? So since we don't know, since we don't know the items inside the list, maybe a list may come as a list of characters or a list of numbers, we just put the question mark. We don't know yet, right? So then use, for example, our for loop object item list and display the element from our list. So do you remember the last time when we were trying to display, when we were trying to loop through elements of we had defined, if I remember it well, we had defined, wanted to display some elements, right? Using generics, but it was about arrays. Let me find it. Yeah, here it is. I guess you remember when we were introducing generics, right? We said that one of the issues that we had is that sometimes you had an array list, but you didn't know what that array list is going to be about, right? So when it was like this, just an array list like this without specifying the type, you couldn't even loop through that array list. right? Because you don't know if the array list is going to be an array list of numbers, an array list of strings, and depending on the data type you are using, sometimes the functions you are going to use here differ, right? So this is when we say it now, this is when you need to use generics so that you can say, okay, this array list can maybe receive only integers, and then here we were able to do this. And now here we come to a place where now we can do it better, right? At that time, we were forced to define our array list as an integer, right? But it could happen to you that you don't really know yet the type of data you're going to receive, and you still need to create your function, right? This is where now the wildcards come. And by providing this question mark here, you say, I don't know yet the data type I'm going to have of this list, but with whatever data type I get, just make sure you do whatever is here. Beautiful. So here, if I would come and define some list items, for example, let me have a list of integers. Let me create it and sorry. Let me create the list and define it immediately. List of and provide elements immediately. You can save some lines of code and time. There should not be any new. So by the way, if you remember, what is the difference of defining a list using list of and doing it like this? Maybe here, let me just use string. Okay, let me just try it like list of string dot add. Maybe let me say off. And on the other side, let me say Millie. Millie, is this how we should summarize your name? I. Okay. So tell me, what is the difference of defining a list? Because all these are lists, and ignore the data types, right? But these are lists. You can see that they are lists. You can define a list like this, or define a list like this. So here we define the list and provided input data, right? And here we define the list and provided data. So what is the difference between the two? Or where do they differ? Or when should I use one and when should I not use the other one? Any idea? People are not allowed to answer are Micheline and who else? I want to hear from others, right? 3 marks. No one wants 3 marks? Yes. Okay.
List. It allows us to make a new application, can add, but list, the dot, I think, you can't make any modification.
Okay. Anyone else? Okay, fine. So please Google the difference between them, right? Or ChatGPT. You need to find and understand. Yes? Yeah, the difference between defining a list like this using list of, and defining a list using, these other functions like add. And people there in the corner here? Really might not understand what you say. Unless you say it in Rwanda, then translate it in English otherwise. Mhm. Yes, then translate it for me. Mhm. Okay. So, others, have you tried to understand the difference? There's someone in the back. You are geniuses, Robert. Yeah. Of course, I'm not giving free marks because you had to research, but that's the answer. So, list of, you provide the items, and that is fixed. You can't modify it afterward, even though we say lists are flexible, right? But when you use list of, it's already fixed. But otherwise, when you define it like this, then you allow it to, be modified, add, remove, and stuff like that, right? Yeah. So now let's continue what we're doing. So here I've defined two lists, and I want to use, sorry, I want to use the function to define below to print list, and I provide list of strings. This is fine. Print list, and I provide the list of integers, and this would still be fine. And this is wildcards. This is why, the use case of a wildcard, right? But now let's even go deeper. So as you've been saying, when dealing with wildcards, right, and even generics, starting with bounded generics and stuff like that, we've been talking about super classes and subclasses. So maybe let's go a little bit backward and create a structure where you can see, like when we are going to create a parent class and give it some child classes, and then apply wildcards on those boundaries, right? So let me create a class and call it animal. And I'm going to create all the classes together so that it can be easy to see them. Here I have a parent class called animal. Let me add a class called dog, which extends the animal class. And here the dog class can override the it function from the parent class. And by overriding it, we can give it a different, let's say, text is dog is dogs, right? And then here we can also, for the dog, since a dog has its way of communicating, here we're going to add and then finally, let's have our main class here. And provide the main function. The main class is going to be, going to rename this. Let me call it wildcard bounded. Since we already have a main class here, so let me rename the file. Oh, here we are. So I guess we until now we all understand that this is a superclass and this is a subclass, right? And a subclass inherits the methods and attributes from the superclass, right? And then you can add some extra stuff you want on your subclass, right? In this scenario, we all understand that, for example, if you wanted, for example, to define animal class, we create two classes, animal dot eat dog dot eat and dog dot up. And we also remember that this is also possible. And we've seen that, for example, if we would say animal ref dot eat, we would, by the way, if you remember well, so what is going to be the output for this? Animal dot eat. Maybe let me come back here. Animal dot eat is going to be this animal eats food, right? So this is the output we are going to get here, right? And here we are going to get this dog eat bones, right? And here the output is going to be the dog barks, right? Okay, fine. This is good, but what is going to be the output here? Anyone else? What is going to be the output here? This dog eats bones. Are you sure? Someone else with a different idea, answer. And What do you think? This dog eats bones, but why? Why not this animal eats food? I think we saw this, right? We had the same question the last time when we were learning, is it polymorphism? Yeah, polymorphism. And we say that all we care about is this, right? Because the dog is a child class of animal. So this the same as we were saying, a string is a number, right? Let's say if you had the number here and the string here, right? A string is a number, so it's fine, right? But we are going to focus on basically when you want to define when you want to instantiate an object, the part that plays the biggest role is this one, right? Calling this dog constructor. Is that clear? So that's why it is going to give us this dog, its bonds, right? Okay, fine. So now that we have a general understanding of like a recap on polymorphism and superclasses and subclasses, now let's apply this knowledge we have here on wildcards, right? So of course, you have already seen the unbounded wildcards where you can simply provide the input here and it is going to use whatever you have. But then you can also want to be specific and say, I'm going to only use upper bounded wildcards, right? So upper bounded wildcards, it's going to look similar to the, was it bounded types, right? And this is how it is going to look like. So for example, here in the main class, I may say, okay, let me create a function and call it, it's a method and it's going to be out here. I'm going to create a method, public static void print animal, print animals, and it's going to print a list of animals, right? And I say, I want to only print a list of animals, like whatever animal which is under the animal superclass, right? So here, let's add another animal here. Let me add the cat class, cat extends animal. So there is not going to be any big difference between these and the, yeah, that's true. Okay, I want to define my own text here and say cat eats fish, for example. So here we have two animals. We have a dog, we have a cat. So as you can clearly see it, a dog and a cat, they are subchild or child classes of the animal, right? So when we come back to wildcards, I believe that you have already seen that you've been doing something that looks like this. Here we are going to apply the wildcard, right? We don't know yet which class we are going to receive, but whatever class we get, it needs to extend the animal class. You get the point? Whichever one we get, it better be from the animal class. And you understand that automatically, the only thing that you're going to print is the dog and the cat, because the dogs and cats extend the animal class, right? So in this scenario, let's just go through it quickly and provide animal. Let's give a complete implementation, animals, and then animal dot eat, right? And this is fine, right? And if we would come here to call this function, print animals, we are allowed to, for example, provide a list of animals. And if I was to provide the list of animals, I would write, here we have a dog. And let me add a cat here. Cat. Right? And I'm going to create a list of all of the list of cats and dogs, right? So let me define it here like this list. And this list is going to be of type animal, right? And animal list you, or let me just say array as list. Bless you. And here we are going to add new animal, new, or let me say, yeah, that's fine. You can use new animal, new dog. Let me also use dogs and cats here. Dog, I can create a list of dogs, list of cats, cat, dog, cat, list. And the funny thing is that, as I was telling you, if you wanted to quickly instantiate an object, sometimes you can skip these things we define here like this. Yes, you see that you have two parts. There is one part here and there is another part here, right? So what you get here is what comes from here. So if you don't want to go aside and define the first card, the second card, the third card, you simply could come here and say new card and come and paste it here. So this is going to be one card and this is going to be another card. This is going to be one dog and this is going to be another dog here. This is equivalent to if you would have to first come here and define the dog one. Let me say dog one, new dog, and define another dog here. This would be similar. So here we just created the list of dogs, right? And provided it here. So if you see this, understand that it is similar to if you would come and define the dogs here and provide the values, the variables here, right? So I just wanted to focus on this print animals function, and I just created some list of animals to provide to my function, to my method. And as you can see, our method is only going to accept things that are either that are like children of the animal class, right? So let's say animal list. This is will be fine because we are still part of the animal list, animal class. And I can also provide dog list, would still work, and even cat list, it would still work, right? So I feel like this is fine, right? This is fine for now, right? So in few words, when you provide the extend, then you understand you're using upper bounded, whatever it is, upper bounded types or upper bounded wildcards, right? And if you can remember it, when we are using, I think we use them on boxes, it's kind of similar, right? So we always provide the superclass when you're using extends, right? So this is the same thing used here, right? So everything else that is here that we don't know yet needs to be a child class of the animal class. And those child classes of the animal classes, they can be either cats or dogs, right? So this is what we call upper bounded wildcards, right? So maybe let's take a short break and then we come back and look at a deeper implementation of wildcards and then lower bounded wildcards, right? I'm not going to stop the recording, so let's just use a few minutes, 5 minutes, right? Because if I stop the recording, then it's going to be 2 different recordings. Yes. Yes.
Like already
When you're using let me see. I have not yet seen, okay. Maybe I have not yet seen where you can use them to define something which is not a list. Have you? On boxes, oh yeah, here on boxes we're just defining types, right? So in fact, these are not just here to define lists or whatever. They're not meant for list only. All they mean is defining a data type that you're allowed to, that you can use. And you remember for array list, for the example I provided last time, you could define an array list without defining the types of information you're going to provide, and that was fine, which means that you can create an array list without using the less or equal signs, right? There's less or equal signs come when you now want to define the type you need to use. Understand why? Right? Yes.
when you define the type.
Mhm.
There's a question that I was doing, and with when you want to define a generic method, also put them before putting the data type of the method.
Generate type.
Generic method, like that one, wildcard, these are the website. I thought you was going to, yeah,
Yeah.
void.
Yeah, I saw we did an example like that one last time. Let me bring it back. Here it was not here. There is a place where this one. Was this something that looks like this? Oh yeah, oh yes, yeah.
So if you are like doing a method, maybe we should rename.
Yeah.
If you want to use the question mark or tick, we also have to put it when you say public, static, and then the lesson.
Yeah. The way it would look like is, for example, you remember this function is not returning anything, right?
Yeah.
So if you wanted to return something, you need to define the return type.
Even if you can't return anything, then it has weight.
No, really? Okay, let's come back and I start with that one, right? Okay.
Yeah, but it doesn't Oh, but you know, Now,
Can we resume? Okay, so let's continue what we are doing. So far we had been able to create a wildcard with an upper bounded, we created an upper bounded wildcard and applied it to this method for printing animals where we can print a list of all animals as long as they are subclasses of the animal superclass, right? This was fine. And something else that you hear people or find often, we call it a read only. Let me find where it is. It is a read only. Can I call it logic? Because you are only allowed to read from a upper bounded wildcard, but you cannot add anything here. So what I mean from this is that, for example, if you wanted to, let's say animal, where is our list? For example, animal list, add, let me say, for example, a new dog. Normally, even though you can see that it is fine, they could still allow us to do it. By the way, let me just remove the dog. Right? This is not allowed, right? Why? Simply because if you say animal list in our animal list, or even let's just define loop cat here instead, right? If you wanted to add a dog here, the thing is, it is a little bit confusing. You don't really know what to expect inside this list, right? You might find that in the list, we just only have cats, right? And therefore, if you add a dog is not of the same type as a cat, even though they are coming from the same parent class, they are not the same data types, right? Simply because here you have some things that a cat can do, right? That a dog can, right? So give me a second. You will fit this one. You fix it one. Are you sure it's this number? Yes. What about some? Those emails, right? What about industry? So, shall we continue? Right. So here, what we were talking about is the I just took the array, the other animals list that add new dog I had here and put it here. So I was talking about the fact that you can only write, only read when using upper bounded wildcards, simply because you don't really know what to expect, right? If you provide, for example, here a list of cats, then if you just want to add a new dog here, it's not going to work, right? And let me just define the dog here by say the dog. And provide it here to avoid errors. So the reason why we are restricted to add anything here is because, remember, the purpose of wildcards is I still don't know what to expect, right? But I know that it is going to be an animal, right? So it can be a list of dogs, it can be a list of cats, or it can be a list of animals in general, right? To display them, it's fine, right? But then adding is not allowed. Why? Because if I get a list of cats, right? How am I going to add cats to dogs, right? They are different, right? If it is a list of dogs and I add dogs here, it might work, right? But since I don't know yet what to expect here, I'm not advised to do anything related to adding, right? This is why we call it a read only, right? You can only read what you have, what people provide here, but modifications such as adding, you're not allowed to do that, right? And then we're going to see the lower bounded wildcards, where now we are allowed to write. Yes, where we are allowed to write and probably not to read. We are going to see that, right? So you need to note this. Note or yes. Let's try and run it. Don't know if it is going to even run if there is still this error here. Do you think it's going to run? By the way, it might run by the way. Let's see. Let me find the main class. This is not the error for that one, by the way. Let me comment this one and run again. I want to make sure that the error I'm getting is related to what we did. So this is not the error we should get. So it's all about the main class. By making sure we have the main class. So let me run from here. Oh. Allow me to separate these classes to reduce confusion. That one was it a dog? That's a cat. It was a cat and class. Yes, sir. Okay, this is awkward. Who can tell us why maybe the reason why we're getting this error? Anyone with an idea? They're telling us that could not find or load the main class. This main class. I don't understand why. Is it the naming different?
The bucket.
Yeah, have it. Yeah, this is the main class. So why does it say they can't load the main class? Okay, what I can see is that it's probably a Java error. Maybe the GDK is not, yeah, it's a GDK issue. Let me find a way I can connect to different GDK. Really? Okay, then I'll need to use a different. Let me just put this code in a different ID. So when you're using Nyarwanda and the recording, these videos are going to be on YouTube. Okay, so you wanted to see what would happen if you run this. So let's do it. So I guess you can see that they're giving an error saying incompatible types, right? Dog cannot be converted to wildcard, right? Extend the animal. The same thing you're saying. You don't really know what is going to be the least expected here, right? So when you just provide a dog, it's like a type error. Like they say, maybe the dog cannot, if someone brings cats, it is going to be an error, right? So this is why we are not allowed to use add functions here. Okay, so now let's look at lower bounded. Let's look at lower bounded wildcards. So now let's see something, another interesting thing. So you see here we have a class called dog, right? And we're going to create a subclass for the class dog, right? Remember we had the animal was the superclass for dog, and now dog is going to be a superclass for another class. So let me call it puppy. And the puppy is going to extend the dog class and override it and maybe let's say that the puppy eats soft food, right? Okay. Now we are going to in our main class here, we are going to do something else. We're going to now try to list elements from let's say a puppy class and a dog class, right? And see, you've seen that, and we are also going to be allowed to add some elements, right? So for example, let's create a new function and call it, this is the first function here. Let's create another function here below and call it add dog. Public static void add dog. And here we are going to do something different from what we had above here. And here we are going to say that we only expect a list of something we don't know. Here we're going to use super, but whatever we're going to add here, it better be dog, right? So in this case, we are allowed to add new dog, and we are allowed to add a new puppy. I guess this one makes sense, right? And you understand the difference between the reason why we are not allowed to add anything here and the reason why we are allowed to add something here. So who can tell me like what your own understanding of this scenario here? Why were we allowed to add things? Why are we allowed to add things here, but we're not allowed to add things here? In your own words. Give me a second. You're going to excuse me. The recordings have been disconnecting here and there. It's probably because the computer is overheating. So who can tell me, I was asking like the difference between the two functions we have here. Why were we allowed to add something here? I mean here, but we're not allowed to add something here. Yes. Okay. Anyone else? Anyone else? Chanel, yes. Okay, that is the way you would memorize it, right? Yeah, whenever you're using super, then you're going to understand that it is lower bounded, right? So yeah, and for lower bounded, we are going to be allowed to add, right? As a way to memorize it, but you need to understand why now, right? So what your colleague said is true. Here, all things that we expect here are going to be dogs, right? Yes. So here we expect a list. That list, whatever it is, it better be a list of dogs, right? And you remember that we have a subclass called puppy, and the puppy is a dog, right? So if this is why here I added a dog and it was fine, and I added a puppy, it was fine, because a puppy is a dog and a dog is a dog, right? Yes.
And super is used when you are saying like the least guaranteed is that type. You can go above the super classes.
Yes.
So how comes in?
Yeah. So here we are saying whatever you put here is going to be a subclass of, if I'm saying it right. I'm confusing it. This is, yeah. Who has a different, who can answer that better? Yes.
We all know animals in the different class that can have the different steps of animals. As you already heard. So for the dog, it's like the parent class of the dog. So I think is the reason why it's always defined that since we use this fucking word. For example, I think for the animals, uh, let's try to extend like for the animals, you can use this fucking word.
Okay, I change it here.
Yeah.
Okay, let me use super here. Sorry. Here it is, right? And the correct words, yeah, sure. Yeah, it. Definitely, what you're saying is true. If you're using super, you can't list, right? If you're using extend, you can list, but you can't add. Yes. Yeah.
It's about for reading.
Yes. Yeah. That's the good way to explain it. Here you can't make any modification. You have the only right to read. You can't update, you can't add anything or can remove anything. If you're using super, you can add, but you cannot read. Understand the logic? Yeah, so I think from here we have a general understanding on what wildcards are and what bounded types are in generics, right? Okay, great. Any question? Okay. So yes.
When you use generics and when you use what are they don't define the exact type to use or when to use.
When to use generics and when to use wildcards? That's a good question. Let me find an answer here. So you see, for generics, we've seen that there are two types of generics, like upper bounded and lower bounded generic, right? Then wildcards, upper bounded and lower bounded generics, right? And when using generics, most of the times you are very specific, right? For example, this is generic. you say integers expect number, right? And then wildcards can be applied to generics, right? It's not about which one to use, but how can you combine them to make the way you specify types more effective, right? Because the first thing we had as a challenge when we introduced wildcards, for example, starting with the box class, we were saying before we would create a box that will receive anything, right? But now we want to be specific, right? So we say, now I need a box that can only accept integers, right? But then we still don't know which kind of integers we're going to get. But we know that whatever it is, it has to be an integer, right? So wildcards come to make generics more, let me say, stronger and more specific, right? Even though generics can provide flexibility, wildcards can do it better. This is why we have even unbounded wildcard. The unbounded wildcard was this one where we just had a question mark, right? So we just say, okay, whatever you're going to put here, it is going to work, right? But in generics, it will say whatever number, right? But here it is going to accept anything. Is it string, number, and you could still be able to read this information. But if you just define generics just as generics as they are, it becomes very hard. Because in fact, in generics, there is no way you can define something like this. Only using wildcards, because here we are not specifying the type we are going to receive, right? Does it make sense? Okay, in a few words, wildcards make generics more efficient, right? You don't just decide when I'm going to only be using bounded wildcards or wildcards only or generics. You use both of them because as you can see, when you're using wildcards, you're also using generics, right? Okay. So let me commit the code and share it to you. And then we call it a day.